Hello, my name is David Ackerman, student number 220310629, and this is the Dynamics Mech 2302 Assignment 5 mandatory. So this is the question where it gives us all the information, and this is the diagram given. Now here we have the question A and question B, one which we'll be answering. Now this would be the diagram where here there's a triangle given that it's 30 degrees. This I labeled point A and the center is point O. Distance from point A and O is 0.3 meters. This is the YYXX and the acceleration the equals 0. So the motion with the XYZ frame with respect to the bigger XYZ frame equals V naught equals A naught equals 0, which means that the angular velocity is negative 15k, and the angular velocity with a dot, it would be 0. This is the triangles that we're going to be, the ratios that we're going to be using later on with the 30-degree that we were given. So the third question is that the motion at point A with respect to XYZ, so the radius of A with A respect to the center is 0.3 j in the j direction meters. The velocity relative velocity with XYZ is negative 25 um, cos 30i plus 25 sine 30j, and then we simplify that into these values. The acceleration relative xyz would be equal to negative 30 cos I plus 30 cos j, plus 30 sine 30j, and we simplify that and we get that. The relative velocity equation is given like this. We substitute all the known values and we compute the cross products and all the additions, and we get that the velocity at A equals negative 17I plus 12.5 j meters per second. The relative acceleration equation is given by this formula right here. Then we plug in all the known values given that the angular acceleration is 0. We compute all the cross products and additions, and we get eventually that the acceleration at A equals 349I plus 597 J meters per second. Sorry, forgot that. My apologies. And the velocity at A equals that, and the acceleration at A equals that. Therefore, that is what I got. And at B, we use a simple kinematics equation, and we simplify it, isolate for the distance D, which we're trying to solve, plug in VAY because it's in the Y direction, so we only need to take the J part of the momentum of the velocity and acceleration. We plug all that in to the formulas, and we get that the change in distance equals 0.131 meters, and the water reached by the pump would be 0.131 meters with the given values. This has been my video. Thank you for listening.